Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from lunchboxsessions.com. A common question about a load sense hydraulic system is how does the pump know to return to the low standby pressure when the hydraulic directional valves are closed or returned to center. In this case, I'm going to add one last brick to the stack on our right-hand motor to get our pressure for the system as high as possible. And what if that pressure for moving those hydraulic motors doesn't go away, but the operator instead just decides to close off the hydraulic valves by returning the handles to center? How will the pump know how to idle down or to reduce its outlet pressure to that low standby value that is so common? Well, notice, of course, on the load sense line, just as the load sense line is about to leave the valve bank, that there is an orifice connected to the tank return line. Very small passage. And that is our bleed down orifice for the load sense line. It could be located in the valve bank, or in some hydraulic systems, it is located inside of the hydraulic pump, where perhaps from this connection node here near the X port, there may be an internal line showing an orifice and then bleeding down into the pump's case. It is not typically in both of those locations, but it has to be in at least one. So that is the purpose of the bleed down orifice, and you will see that as the directional control valves are returned to the center position, which blocks flow from the pump, which you might think leaves us in a high pressure condition, that no, the load sense line bleeds down and the pump knows as the signal line from the load sense port on the valve tells the pump that there is no load pressure worth reacting to at this time. So even though there's still bricks on the brake shoe brick stackers, and the motors when they start up will be under very heavy load, at this moment when there's no flow demand, it is best to let the pump idle down to that low standby pressure. So now the pump is at both low displacement and low outlet pressure, and we're saving lots of diesel fuel if this is a piece of mobile equipment, or we're saving lots of electricity at our electrical prime mover if this is an electrically operated machine. That's all for this time. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.